energy consumption, here's some statistics. Transportation accounts for nearly 25% of the world energy consumption, 60% of the world's oil consumption, and 47% of that is dedicated to land transportation. I like this slide. It's a question of billions of barrels of oil and what the peak production year is. This predicts a 2010-12 peak production year. But I think it needs to be said in the interest of truthfulness that this kind of prediction of peak production and reduced oil supplies because of depletion seems to be something that slides forward as new discoveries are made and new techniques are used. For instance, in North America, the fracking has really had a dramatic impact on oil production. But still, as a matter of principle, we would like to reduce oil reliance and oil consumption. So again, making a comparison based on one corridor, the Paris-Marseille corridor. Again, the similar bar chart with the consumption efficiency dramatically in favor of the rail mode. So looking at the energy consumption at each stage for the conception phase, improve the alignment to minimize acceleration and deceleration requirements, design the rolling stock to minimize its aerodynamic impact and air resistance. At the construction phase, work very closely with the way materials are delivered to the work site, trying to rely on rail feeding. And then for operations, trying to reduce all the environmental and energy requirements during operations. And here's a goal that has been set by the SNCF in France with respect to a reduction in the consumption, about 12% to cut from the current utilization of, and utilization being translated into cost, 800 million euros for traction and buildings, 700 for traction, 100 for buildings. And they're moving through the system looking for ways to cut that by 12%. Some of the methods already implemented by the French National Railroad improves time schedules to avoid acceleration and braking using software, and then instructions to the operators, regenerative braking, which adds energy back into the system, changes to the air conditioning system technologies to reduce the cost, and better designs, more green designs of all of the administrative buildings and stations. With respect to end of life, again, trying to design lighter trains, recyclable material, and less material. With respect to the impact in the land of acidification of soils and waters due to the impact of emissions, there's a significant science about nitrous oxides, carbon monoxides, methane, etc., and the rail mode reduces the impact on the human environment of those things because the high-speed rail lines are 100% electric rail traction. There's no local air pollution except from electricity production, which has really taken a great deal of attention to reduced emissions. And so there is no direct local air pollution from high-speed lines. Here's a chart that shows the comparison for each of these areas of the high-speed rail mode with competing aircraft and car modes, showing the very, very low contribution to local air pollution by rail. So from a conception point of view, try to reduce the energy production emissions, and that is working with the electric utilities, working at the substations, and trying to take a multimodal approach to make it most efficient to move from road and air to the high-speed rail system and have the maximum modal shifts. And then for construction, feeding at the work site by rail, using non-air polluting generators at the work sites. And one of the areas of concern is braking and particle emissions, and there's a lot of work and research being done to find less polluting materials and improving the design of brakes. Another significant impact that requires consideration is noise and vibration. Here's just a simple chart of decibels and the measurement of decibels and what the risks are. So you're looking at 40 decibels. Sleep is disturbed all the way to 100 decibels where you have hearing impairment risks. Noise and vibration is a significant issue on high-speed trains. They're moving very rapidly. They have wheel-to-rail noise propagation, the aerodynamics of the pantographs, which are drawing power from the catenary, the aerodynamics of the rolling stock itself. There's a great deal of work to reduce these sources of noise. And we have rolling stock improvements, new designs for pantographs, working at tunnel entrances and exits to avoid the propagation of sonic booms, looking at, track design to minimize the noise of the vehicle rail track interface, and at stations trying to mitigate noise propagation as trains enter and leave the stations. On the right at the bottom, there's a viaduct design showing some changes to the barrier that has a better noise propagation mitigation impact. And looking at on the left, the design of the structure from the point of view of noise propagation. Here's a typical station with acoustic absorption on the extension roof above the platforms, trying to have loudspeakers installed in a way to reduce the actual noise that is made by the loudspeakers, basically focused on the actual message. On the construction site, creating silence generators and pumps, using equipment that conforms to noise regulations, which means mitigating the noise, and monitoring noise and vibration so that community impacts can be mitigated. With respect to operations, limiting speed when crossing urban areas, trying to divert freight traffic from urban areas so that they move around the area on alignments that are far outside the dense area, and solutions including noise barriers, isolation of the track from the environment, better ties with respect to the propagation of noise, improving freight rolling stock, which is not a passenger issue, but in Europe there's a lot of freight trains, and that's an important area of noise mitigation. And then using absorbers to reduce noise. I think the best practice discussion about Japan is important because the Japanese rail operators have really spent a huge amount of money and time and energy researching noise propagation and reducing their noise propagation. And here you can see they've used rail grinding, cables, speed increases, pantograph shields, carriage design that is more aerodynamic and less noise propagating, low noise carriages and bogie design at the bottom of the rolling stock. So each of these activities, as speed has increased in Japan, noise has been reduced. We're going to just go for a few minutes about biodiversity. We are concerned about wildlife mortality and disappearance, in looking, first of all, to find where there is endangered flora and fauna, how we can mitigate that. And here's a typical wildlife overpass created solely to permit the wild animals of the area to move across the right-of-way without entering the right-of-way. Oops. So the layout of the design is informed by the research about wildlife and about flora and fauna, trying to avoid the most sensitive areas, restoring permeability, the ability to go across the right-of-way for small and large animals, trying to create fences that secure the right-of-way and take into account the actual population around the right-of-way. In the construction period, identify what is to be protected, avoid pesticides, monitoring all transfer operations, and then during operations, strictly following the methods and operating proposals that were made during planning, and making sure that no incidents take place that might endanger flora and fauna. Here's a kind of network of ponds that was created to protect species of frogs, and this is a not unusual method of preserving biodiversity and the areas through which the alignment is being constructed. So in terms of landscape and cultural heritage, we worry about visual intrusion, landscape fragmentation, and this is an issue of direct importance in the California project right now. The destruction of cultural or historic heritage sites, that is a definite something to be avoided. Look at landscape integration, really taking a holistic look at how the alignment is going to impact on the landscape. Creating compensation to assist landowners whose land is being divided from the impact, and respecting corridors that are streams, biological corridors that are important. That's a roundup. It gives you a sense of some of the attention to detail in the entire area of sustainability. The high-speed rail programs in Europe and in Asia are proud of their contribution to sustainability.